record. There we go. All right, now it's recording. So my Zoom room link is there. So if you're absent for any reason and you want or need to join in with class, you can click that. But it's also in the updates. I don't have a different Zoom for my different classes. It's just my personal Zoom room. So like here in the intro, you just click that and then I let you in. But every class is also recorded and then I upload it to YouTube. So whenever class is done, if you miss anything, you can find what we did. Besides in the materials, my Zoom room, there's this thing that says student and parent resources. That's where the syllabus is. You got a physical copy of that right now. And then I'll load the other chapters as we go. But we start off in order and what's in the textbook. If you're remote, you want to come and get a textbook from the high school if you can. Otherwise, I have a digital copy of the textbook that you can reference. And for here, the textbook itself, you got a copy of it. It was sitting right up there. I put it somewhere. Where did I put it? My book is gone. It's blue and it's got like oceans on it. Oh, I just have one up here. These books will be underneath your desk. This course is new to us starting last year. And I was able to select the textbook. And there's not too many textbooks, but this is like the prom textbook for oceanography. It's written by two people who teach oceanography at a community college on the west coast of California. And the book's been around, it's in its 13th edition. And it's just gorgeous. Like the illustrations and the descriptions of how the earth works is incredible. If you're a visual learner, you like to look at graphs and charts and maps and things, this course will be useful to you. A lot of ways that we visualize the way the earth works is through charts and diagrams. I'm a pretty visual learner, so it's helpful to me. But there's lots of good diagrams, which are just incredible. Every page is mostly full of diagrams and charts and stuff, describing like your ocean circulation and stuff. These books will be underneath your desk for you to use for your reference. And the order in which we go through things in the course is the syllabus is also like right inside on the page. I'm not going to issue them, but if we find out that we're going to go remote, like if they're like, okay, we're going to go out for like 2 weeks or a month or something like that, then I'll like issue them. Does that make sense? But the thing is, because it looks like we're going to be here for a while, if I give you one now, then you're going to have to bring it. We're going to use these in class as long as we're full time. I only have one set. These are really expensive. They were, I think they're like 180 or 200 bucks. That's how much like textbooks cost. That's how much like college students pay for books. They're pretty expensive and they need to stay in good shape because they've got to last for 10 years or so, give or take, or whatever like that. I don't have a second set. So that's the book itself. In every week, or for every chapter, in every folder, there's a file that says plan for the week. That plan for the week will tell you like what we're going to do. So here it says like welcome to oceanography. You got the seating chart, you got the syllabus chapter 1, thing about the textbooks. So it's kind of like, so I know what I need to tell you and what we did in class. So if you missed it, you can see it. And then right beside the date, it'll say Zoom recording. So, later on today, once I get a chance, I'll like save it, save the Zoom, upload it, and then the Zoom recording will be here. So if you ever miss, you can see it. So if you're absent, you can join the Zoom or you can like straight up watch it. So that's how that goes. There's a discussion you should participate in. It says your interest in oceanography. I'll tell you more about that tomorrow, but you can join in on that. Just why did you decide to take this class? Like, what do you want to do? I added something just so you can see like what would be good to write about. And then I don't know what else. There's a PowerPoint slide in here, and then there's a quiz at the end of each of the chapters. And that's not on right now, but it will be. But in every chapter, there's materials that's good for you to be able to learn from. Another folder that's in for the course is this folder that says web resources. So there's lots and lots and lots of really, really good websites that are excellent to help visualize and get data from the Earth itself. One of the really good ones, this is just an incredible website. me shut one of these lights off. This site's just fun to go to, just anytime to see what's going on in the ocean around the Earth. This is a website called earth.nullschool.net, and it is real-time information about the Earth. And right now, this is set on a setting that tells you about, I don't even know what setting it's on. Oh, this is a wind setting. So this actually shows, like, right now, the direction and speed of the winds on the Earth, which is useful like in meteorology. So I can tell right now it's calm outside because it's just kind of blue. But if you're up here, these are really heavy winds. But we can also go to like the ocean tab and click on like ocean sea surface temperature. So this shows like the temperature of the ocean in different places on the ocean. And there's also currents shown on here. So like the Gulf Stream is clearly shown. That's a big ocean current off the East Coast. This is real time. This is from real-time satellite data. And it's an excellent tool to help us like see things that are happening on the Earth all over the place. You can collect data. If I want to know what is the temperature in a particular place, you just click it, and then down in the lower left-hand corner, it straight up tells you like what the temperature is right now. Latitude, longitude, wind speed, everything you'd ever want to know. Up here, it's real cold, like 0.1 degrees Celsius. It's just above freezing, or just above the freezing point. And then down here at the equator, 28 Celsius, that's pretty warm. I don't know, so it's like just short of 58 and 32, right around 90 degree Fahrenheit water. So that's pretty warm water. Anyway, so those links are in the web resources for both Google Earth. So it's like Google Maps, but the round Earth mapping program, and the link to my YouTube channel is there. I'll show you some stuff on my YouTube channel that's related to this class. We'll use a bunch of different YouTube things. Not that this class is all YouTube, but it's a lot of excellent stuff in oceanography and marine science on YouTube. All right, so in the grading section on the syllabus, there's a thing about aquarium maintenance and class participation. As we go through the course, we'll hopefully be able to do work with the aquarium systems. And then we grow coral here that we sell. We raise clownfish. We breed and raise baby clownfish from time to time, which is pretty exciting. And the sale of clownfish and coral and things is how we fund the aquariums. The school does not pay for the aquariums here. All the aquariums in the school gives us the space and the electricity and the water, and then I fund everything. We do it through fundraising. We get grants. We get donations. I resell things. But it's part of a nonprofit educational organization. So if anybody's ever like, I can't believe the school spends money on aquariums, they don't. You won't find a penny in the school district's budget, except for the electricity and the water. We don't use that much water. And though it might seem like we use a lot of water, we don't really use a lot of water because it just stays in the tank. We'll have quizzes at the end of every unit. There'll be a final exam at the end. And you can read other stuff that's in there too. Other things, if you ever need to use the restroom, up on top of the file cabinet, there's a little plastic dish that's got little yellow passes. You just take it and just go. There's Kleenexes up on top there. If you need to go to the nurse, just let me know. Like whatever. I'm pretty chill. I'm pretty easy to get along with. But I enjoy oceanography. I enjoy this course. It's a great course. My school year is very, very, very hectic this year. I have a different class every class period. I have one class twice, but I have 5 different courses, but one of them has a separate remote course. So I'm actually teaching 6 different courses this year, which is an awful lot. So luckily I've got the whole oceanography course. We've been through it in the fall semester. So most everything's already built on Schoology, and now we'll get to refine it a little bit. But I'm going to do my best to help you learn as much as I can, as much as you can, with the limitations we have with social distancing and mask use, and with whatever time we've got. We have to be very careful about the way in which we do labs to make sure that we're like safe in the lab too. Okay, what time is this thing over? 10:56. All right, so any questions about anything before I want to show you a couple videos, and I'm going to let the remote students go so that they can like watch the videos like separately. Anything, any questions for me, about me, anything about the class, anything at all? It's kind of like what we're doing. Yep. Use the restroom? Yeah. Anybody else? No. All right. And if you're remote, if you want to put something in the chat, turn on your mic. My speakers are on, I think. Just kind of holler at us. You can just put something in the chat, be like, yo, what's up? There's actually only 3 people now, but that's all right. Okay, so if you're remote, I'm gonna let you go, but the thing to do is in the materials in chapter 1, where it says plan for the week, there's 2 videos here. One that says how big is the ocean? And the other one says how did Polynesian wayfarers find their way around the world's oceans? And these both give you an idea as to like just this massive scale of what we're studying in this course. And then much of the way, like as humans, we live on land, and the land ends at the ocean. But we've always used the oceans for transportation, for navigation, for exploration. And part of, like a big part of history and like history class is like these great explorations, like Magellan and Cook and Columbus. Well, Columbus isn't that great. Kind of, we play him up a lot in the United States, but as an explorer, it's important, but not so important. We're going to look at some explorers, but people get around the Earth using the ocean, and that can be like historically very challenging. These days, we just have GPS and all kinds of great engines and stuff on our ships, so it's not a big deal. But although people still make mistakes, but back in the day, it was a bigger deal. All right, so if you're remote, watch those 2 videos. I'm gonna try to get those running here. I have to like switch some stuff around. Let's see. I gotta click. I gotta get out of the YouTube or out of the Zoom on that. Watching it through Zoom is like garbage. Get to this thing. New. And like the screen resolution is different for the computer than it is for that monitor, and it's different for this projector. So okay, I think I've got sound hooked up right. It'll only be on that one.
Imagine yourself standing on a beach, looking out over the ocean. Waves crashing against the shore, blue as far as your eyes can see. Let it really sink in, the sheer scope and size of it all. Now, ask yourself, how big is it? How big is the ocean? First thing, we need to understand that there really is only one ocean, consisting of 5 component basins that we call the Pacific, the Atlantic, the Indian, the Arctic, and the Southern. Each of these 5, while generally referred to as oceans in and of themselves, are really and truly a part of a single massive body of water, one ocean, which defines the very face of planet Earth. The ocean covers roughly 71% of our planet's surface. some 360 million square kilometers, an area in excess of the size of 36 USA. With such a vast spread, when viewed from space, the ocean is, by far, the dominant feature of our planet. Speaking of space, the ocean currently holds over 1.3 billion, that's billion with a B, cubic kilometers of water. Put another way, that's enough water to immerse the entire United States under a body of salt water over 132 kilometers tall, a height well beyond the reach of the highest clouds and extending deep into the upper atmosphere. With all that volume, the ocean represents 97% of Earth's total water content. On top of all that, the ocean contains upwards of 99% of the world's biosphere. That is, the spaces and places where life exists. Now let that sink in for a second. The immediate world as we know it, indeed, the totality of all the living space encompassed by the continents themselves, all of them represents only 1% of the biosphere. 1%. The ocean is everything else. So, the ocean is physically massive. Its importance to life is practically unparalleled. It also happens to hold the greatest geological features of our planet. Quickly, here are four of the most notable. The ocean contains the world's largest mountain range, the mid-ocean ridge. At roughly 65,000 kilometers long, this underwater range is some 10 times longer than the longest mountain chain found purely on dry land, the Andes. Beneath the Denmark Strait exists the world's largest waterfall. This massive cataract carries roughly 116 times more water per second over its edge than the Congo River's Inga Falls, the largest waterfall by volume on land. The world's tallest mountain is actually found in the ocean, hiding in plain sight. While 3,200 meters of Hawaii's Mauna Kea sit above sea level, its sides plummet beneath the waves for another 5,800 meters. From its snow-covered top to its silt-covered bottom, this Hawaiian mountain is roughly 10,000 meters in height, dwarfing tiny Everest sculptured peak by well over a kilometer. And since we're picking on poor Everest, let's consider the world's deepest cave, Challenger Deep, existing 11 kilometers below the ocean surface, some 6 times deeper than the Grand Canyon. That's deep enough to sink Mount Everest into and still have over 2.1 kilometers of water sitting atop its newly submerged peak. Put another way, the depth of the Challenger Deep is roughly the same height that commercial airliners travel. So, pretty much however you choose to slice it, the ocean is capital B, capital I, capital G, big. It defines our planet, home to the greatest geological features, comprises the largest living space, and accordingly is home to the greatest numbers and forms of life on Earth. It is practically incomprehensible in scope. But it is not so big, so vast, so extraordinary as to be untouchable. In fact, with roughly 50% of the world's population living within 100 kilometers of the coastline, and with most of the remainder living close enough to lakes, rivers, or swamps, all of which ultimately lead to the ocean, virtually every single person on the planet has the opportunity to influence the general health and nature of the world ocean. Evidence of human influence is seen in every part of the ocean, no matter how deep, no matter how distant. The ocean defines our planet, but in a very real sense, we define the ocean.
So the deal is, much of like the science that you've always studied has focused on land. It's focused on life as like animals and humans and stuff. 97% of the world's water, 97% of the world's water is in the ocean. The remaining 3%, 2% is frozen as ice and glaciers. Only 1% of the world's water is like drinkable, potable, rivers and lakes. So the vast majority of the world's water is in the ocean. 99% of life is in the ocean. Life is so diverse in the ocean that every time that we dive down and a new exploration to try to like find other forms of life, we're never let down. Always discover something new. It's not as if you think we're going to die today and see something new. The answer always is yes. Always find something new because the amount of diversity of life is just incredible. The world's greatest geologic features are in the ocean. They're not on land. So in some ways, like we're focused on land because we live on land. But the real story of the planet is the ocean. That's the real story of the planet. That's the true story of the planet. It's not just like an egotistical way to look at it. It's just true. There are many places on Earth is sort of devoid of life and pretty dry, but the diversity of types and forms of life in the ocean is great. The very air we breathe, the oxygen that you depend upon, is made in the ocean. Yeah, trees make oxygen, but not much. It's cyanobacteria in the ocean that made the atmosphere to have oxygen in the first place and continues to produce massive amounts of oxygen. Cyanobacteria is a type of bacteria that makes oxygen and never consumes it. Trees consume oxygen whenever they undergo respiration. So it's not that trees only make oxygen and don't consume carbon, don't consume it. Trees also consume oxygen. They just have a net balance of oxygen gain. So the oceans are very, very, very very key to life. We owe the fact that Earth is habitable to the ocean, not to the land. It's all about the ocean. So, I mean, you've kind of like, maybe in some other class, you like labeled things on a map and you labeled the oceans. And you're like, that's it. Maybe in biology, we talked a little bit about the ocean. But what we focus on in this course is understanding and exploring the ocean. We're surprised all the time about the ocean. We learn new things all the time. People say stuff like we know more about the surface of the moon and more about the surface of Mars than we know about the ocean floor. And in a lot of ways, that's true. The ocean floor, we can map it generally, but to go to every point on the ocean and like look at absolutely everything like we've done on land is really hard because a lot of it's incredibly deep and very difficult to get to. It's very expensive. Ships cost a lot of money. It's really expensive to do oceanography. Like if you want to figure out, hey, what's alive on top of that mountain? You just hike up the mountain and look and see. But you want to discover something that's 3 miles down the ocean. You know, you're talking about a multi-million-dollar ship, very expensive robotic stuff to be able to even see like what the heck is going on. I mean, hopefully that's kind of impressive to you, even. You may have known some of those things, but the beginning of the textbook focuses on the idea about the ocean as a whole and how we understand the basic stuff about the ocean. So this other one that's really cool is about travel and transportation. Let's see. And there's a second one that like follows up that we'll watch whenever we talk about exploration and wayfinding. This one's pretty good. So, and just to show you where this video refers to things, let's do this. I don't want to do that. All right, so if you go to like Google Maps, you know, you might use Google Maps to like find a location or to map stuff or something like that. But in Google Maps, you can zoom out and you can change to satellite. If you switch to the satellite view and you keep zooming, the Earth goes from being flat to being a spherical representation, like a big ball. One of the more impressive things is if you go on the Earth to look at the Southern Pacific Ocean, you can completely get rid of land altogether. From this point of view, Hawaii is like up in here somewhere underneath those clouds. But from this point of view, from the Southern Pacific, the Earth is all just a big old ball of ocean. Most of the time, when you look at the Earth from space, you see ocean, you see water. So this video deals with Polynesian explorers. So I'll show you where we're going. I don't know why I don't want these clouds. We'll just do this. Okay, so here's the Earth. I'll go over here. This is like North America. We're right up here. To the west of us is the Pacific Ocean, and the Pacific Ocean has a whole lot of nothing, but there's where Hawaii is, and this video mentions Hawaii, which is important. There are some other islands that are throughout the Pacific Ocean, down in this region, but most of the people are talking about as Polynesians are people who are native to like the Philippines, Indonesia, Malaysia, Papua New Guinea. This region of the Pacific Ocean between Australia and Asia has a rich history of seafaring, of ocean going, because really this is an area of the Earth where lots of people live on lots of islands. In other words, if you zoom in here, you see lots and lots and lots of very small islands. And you might think, oh, you can see one from another, but you can't see these islands from each other. There's the Earth curves enough that they're not visible. So you have to have a way to figure out how to navigate between the islands. And some of the islands are incredibly tiny. They hardly exist. And even in this video, they talk about explorers leaving from Indonesia, traveling over open water the entire way to Hawaii with nothing in sight.
Imagine setting sail from Hawaii in a canoe. Your target is a small island thousands of kilometers away in the middle of the Pacific Ocean. That's a body of water that covers more than 160 million square kilometers, greater than all the land masses on Earth combined. For thousands of years, Polynesian navigators managed voyages like this without the help of modern navigational aids. Ancient Polynesians used the sun, moon, stars, planets, ocean currents, and clouds as guides that allowed them to see the ocean as a series of pathways rather than an obstacle. Their voyages began around 1500 BC, when the people who would settle Polynesia first set sail from Southeast Asia. Early Polynesians eventually settled a vast area of islands spread over 40 million square kilometers of the Pacific Ocean. Some historians believe the voyagers moved from place to place to avoid overpopulation, others that they were driven by war. Voyages became less frequent by around 1300 AD as Polynesian societies became more rooted in specific locations. During the voyaging period, successful journeys depended on a number of factors: well-built canoes, the skill of navigators, and weather being some of the biggest. Voyages relied on sturdy ba'akalua, or double-hulled canoes, which were powered by sails and steered with a single large oar. Canoe building involved the whole community, bringing together the navigators, canoe builders, priests, chanters, and hula dancers. Navigators were keen observers of the natural world. They were abundantly familiar with trade wind-generated ocean swells, which typically flowed northeast or southeast. By day, navigators could identify direction by the rocking motion of their canoes caused by these swells. But sunrise and sunset were even more useful. The sun's position indicated east and west and created low light on the ocean that made it possible to see swells directly. At night, navigators used something called a star compass, which wasn't a physical object, but rather a sort of mental map. They memorized the rising and setting points of stars and constellations at different times of the year. They used those to divide the sky into 4 quadrants, subdivided into 32 houses, with the canoe in the middle. So, for example, when they saw the star Pira Atea rising from the ocean, they knew that to be northeast. They had some other tricks too. The Earth's axis points towards Okupa'a, or the North Star, so called because it's the one fixed point in the sky as the Earth rotates, and always indicates north. However, it's not visible south of the equator, so navigators there could use a constellation called Nig, or the Southern Cross, and some mental tricks to estimate where south is. For instance, draw a line through these 2 stars, extend it 4.5 times, and draw another line from there to the horizon. That's south. But the sky also contains navigational aids much closer to Earth: the clouds. Besides being useful weather cues, under the right conditions, they can indicate land masses. For instance, the lagoons of Pacific atolls can actually be seen reflected on the underside of clouds, if you know what to look for.
and high masses of clouds can indicate mountainous islands. Once navigators neared their destination, other clues such as the flight patterns of birds, floating debris or vegetation, and types of fish in the area helped determine the proximity of land. For example, the Manuoku had a known flight range of 190 kilometers and could be followed back to shore. So how do we know all of this? Partially through evidence in petroglyphs, written observations of European explorers, and Polynesian oral traditions, but also by trying them out for ourselves. In 2017, a voyaging canoe called Hokulea completed a worldwide voyage using only these techniques. If that seems remarkable, remember the ancient Polynesians, who through close study and kinship with nature were able to forge these paths across an unfathomably vast, vibrant, living ocean. The educator behind this lesson.
All right. So these large voyages that took place in the South Pacific, started 3,000 years before Columbus left Europe, 1500 BC, like 3,500 years ago. And the remarkable precision of their navigation depends upon knowing all kinds of stuff about the ocean, about currents, about waves, about wind, about the relationship between the earth and the stars. And you're able to like leave Indonesia, head out on a double-hulled canoe. 2 months later, end up in Hawaii. It's a little tiny speck of land. And I've been to Hawaii and I've gone from island to island by boat. And when you leave an island, you get heading out on a boat. You're like 20 minutes away. That island's gone. It's just not there anymore. You're surrounded by open water and you're like, oh snap. Then you just keep on going. And all of a sudden a new island pops up. And those are islands that are very close to each other, right up against each other on a map. But of course you've got like, modern navigation techniques. So we have a long history as humans of understanding things about the ocean. It's just different people around the world have come to that fact at different rates and understood things at different times. So a lot of the history you learn is like based upon European traditions or like, things that happen in Europe. And we find that there's plenty of oceanography that comes about from modern oceanography that comes from traditions and learning that goes back thousands of years to people all over the world. There's people all over the planet have used water to explore and navigate, spread out, get natural resources, trade, fish. Didn't mention in that one video, but over half of the world's population gets the majority of their protein from the ocean. Like here in Williamsport, like you might go to Red Lobster, eat seafood once in a while. In a way, like people live in Pennsylvania, seafood's like, you don't have their protein source, maybe a treat, maybe you don't even eat seafood at all, maybe your family just doesn't eat it. But about half the world's population depends entirely on the ocean for food. Without fish from the ocean and shellfish, they die. It's half the population. Because most people live pretty close to the water. So that understanding ocean resources as a food source is going to be a very important topic in this course. Protecting the oceans and making sure that we can like sustain fisheries. If you overfish a type of fish in a certain area, you could possibly make it go extinct. But the bigger concern is if you overfish, then the population of fish has declined enough that there's not enough food. And people get desperate and then they fish even more and then there's even less to reproduce, All right, we're almost out of time. I don't know. So the syllabus, you can read through other parts of that. The study guide I gave you, some of the things in the study guide were actually just in those videos, but the study guide really has like questions and thoughts and ideas about topics that are in chapter 1 of your book. Tomorrow I'll go over some of the stuff specifically in detail, but we're gonna take other time this week to use the textbook to help you learn some basics about the ocean itself. Sound good?